Today we're going to spend a few minutes, short video, talking about how to add and subtract radical expressions. So basically, there's one rule. If you're going to combine these, the radicands, what's called the radicand, that's the guy under the radical, has to match. As long as those match, you can add them or subtract them. Sorry, I guess my hair. Well, in this case, we have a 3 root 2 and a 4 root 2. Guess what? They're both root 2's, so we can add them together. A 3 root 2 and a 4 root 2 would make 7 root 2. We don't change the radicand. We just have this many root 2's and this many root 2's, so altogether we have this many root 2's. This is the same exact thing, but sometimes we get confused because we don't see a number in front. There is a number there. You know what that number is. There's a 1 there. So we have 1 root 3 plus 1 root 3. That would make 2 root 3. Six root 7 minus 2 root 7. Well, once again, the root 7's match. So 6 root 7 minus 2 root 7 will leave us with 4 root 7. Uh-oh, look here. 6 root 7 plus 7 root 2. Wait a minute. The radicands, that is, the number under the radical, they don't match. So guess what? That's already simplified. You cannot do anything to 6 root 7 plus 7 root 2. It just stays that way. Let's look up here. I have a root 2, a root 2, and a root 3. Remember, to add and subtract, the radicals must be, the radicands, the number under the radical, must be the same. So since I have 8 root 2's and 3 root 2's, I can combine those and get 11 root 2's. But I still have minus 4 root 3, and I can't do anything with that. So I have 11 root 2's minus 4 root 3's as my final answer. Oh my. I have a root 12 and a root 27. Well, this goes back to another video, the video about simplifying radicals. Certainly, these cannot be added the way they look right now, but 12 breaks down. Remember how we did that? 12 breaks down into, let's say, 2 times 6, and 6 breaks down into 2 times 3. So we have prime factors of 2, 2, and 3. We're doing a square root problem. Remember, we look for groups of 2. So we will take out the 2, leave in the 3. If that confuses you and you haven't yet watched the simplifying video or simplifying radicals video, you probably should watch that one and then come back to this. So root 12 comes down to 2 root 3. What about root 27? Well, it also breaks down. 27 is 3 times 9. 9 is 3 times 3. So we have prime factors of 3, 3, and 3. Again, in a square root problem, we're looking for groups of 2. So we have 2 3's and an extra 3. There's the 2 that are coming out. They make a 9. The square root of 9 is 3. But that guy's left over. This is an addition problem from the beginning. Now look at what happens. We have 2 root 3's and 3 root 3's, so we end up with a grand total of 5 root 3's. In the beginning, we could not add these, but after we simplified them, they were addable. Please note, that did not happen in this problem because 7 does not break down, and 2 does not break down. So there was no chance of simplifying these radicals to make them add. Always break down your radicals, if possible, to see if you can add them or subtract them. All right, here we have kind of the same thing. I have a square root 32 and a square root 8. They do not add. However, 32 and 8 both break down. So I'm going to put this 2 on hold for a moment, and I'm going to focus my energy right here on the 32. So let's see, 32 is 4 times 8, which is 2 times 2, and 2 times 4, which is 2 times 2. Again, if that's confusing to you, please go back and watch the Simplifying Radicals video, and then come back to this one. The prime factors for 32 then, I'm just looking right here. The prime factors are 2, 2, 2, 2, and 2. Now, when I am doing a square root problem, I am looking for groups of 2. So I have 2 here, the group of 2 here, and a group of 2 here. So when I simplify this, I'm going to take out a 2, take out another 2 for a total of 4, and have a 2 left over that I can't pair him up anyway. But don't forget that guy. There's a 2 being multiplied times that square root 32. So the square root of 32 gave me this, but now I have to times it by 2, so the total there, that simplified expression is 8 radical 2. Now guess what? We get to do the same thing here. Again, keep that on hold for a moment, and let's look at the 8. That's 4 times 2, 2 times 2 times 2. So here are the prime factors of 8. So there's one group of 2 and one left over. But that is being multiplied by a negative 5. So this is actually negative 10 root 2. The square root of 8 breaks down to this. But we have to multiply by the negative 5. So that's how I got negative 10. Now I have 8 root 2 minus 10 root 2. Well, 8 root 2's minus 10 root 2's will be negative 2 radical 2. There is our answer. Ooh, those can be a little complicated. Let's try a couple more. Just 2, and we'll be done. How about this one? Now, none of those add up. Right now, none of those add up. However, some of them do simplify. The square root of 5 does not simplify. So we're going to keep him the square root of 5. What about 20 though? 20 breaks down. 4 times 5? 2 times 2 times 5. So the prime factors of 20 are 2, 2, and 5. Remember, when I take a square root, I'm looking for groups of 2. Here is a pair. So out will come the 2, and in will stay the 5. Remember, whatever gets paired up comes out. Whatever is alone stays in. So I had my root 5 from the beginning. Couldn't do anything with him. Now I've taken care of my root 20. He's now 2 root 5. And now I'm going to do 125. 125 is 5 times 25. And 25 is 5 times 5. So the prime factors of 125 are 5 times 5 times 5. So whatever I have a pair of comes out, and whatever I don't have a pair of stays in. Well, look at this. We have 1 root 5, and 2 root 5, and 5 root 5. So the problem that looked like it didn't simplify in the beginning actually adds up to 1 and 2 and 5. That makes 8 root 5s. One more. And then we'll be ready to practice a little bit on your own. Let's take a look at this one. At first glance, we're not going to be doing any adding or subtracting because our radicands don't match. We have a 7, a 10, and a 28. So we need to simplify anything that will simplify. How about this one? Does that simplify? No. 7 doesn't break down. So that's just going to stay 3 root 7. How about the square root of 10? Now, 10 does have factors. You can break 10 down into 2 times 5. But what's wrong with that? Why does that not help me? Because when I do square roots, I need groups of 2. And there aren't 2 of anything. So that's just going to stay the square root of 10. How about 28? Well, 28 is 4 times 7, or 2 times 2 times 7. So the prime factors of 28 are 2, 2, and 7. Remember, in a square root problem, you're looking for groups of 2. So there are 2 2's. So out comes the 2. There's only 1 7, so in stays the 7. Remember, when you break down square roots, you're looking for groups of 2. And anything that's a group of 2 comes out, anything that's alone stays in. Be careful. That 2 root 7, which is the square root of 28, is being timesed by negative 5. So that's going to give me, if I take negative 5 times 2 root 7, that's going to give me negative 10 root 7. Now everything is simplified, broken down as far as it can be. Does anything add? Well, look, you have a 3 root 7 and a minus 10 root 7. They have the same radicand, so they can add. That will be negative 7 root 7. What about that guy? He just hangs in there. He doesn't combine. He's a radical 10. Radical 10s don't combine with radical 7s. So your answer is negative 7 root 7 plus the square root of 10. All right. Now you have a chance to practice some on your own, and the answers are provided. Have a great day.